Hello, everyone, and welcome to another AMA. We have people connected from all over the world. We want to welcome you all from all the continents. We see people from Asia, from Europe, from North America, South America. This is the HS50 community, literally people connected from all over the world for the uniqueness of Hill, which is keeping the world updated about the development of this aircraft that is coming just about to be completed at the end of this year. So today we have another AMA, and Jason's going to share a lot of things. We're anxious to hear that. And Misha, you can tell us what's going to be the agenda for today.
Sounds good. You guys, it's another usual AMA, but lots of exciting things on the roster. Jason was just giving us an update of what he's going to be covering tonight, and I'm very excited to be seeing all of those things coming up very quickly here. So Jason's going to update for about 45 minutes like he usually does. And then at the end, we're going to take everybody's questions as we always do. So we've got the chat. You guys can start posting those questions right now in the chat, and we're going to start taking note of those, and then we're going to present those to Jason at the end. And we're going to take about an hour at the end, about an hour and 15 minutes to be able to answer hopefully everybody's questions. So really looking forward to that. Start getting those in there. And without further ado, we're going to pass it over to Jason. Jason Hill, founder of Hill Helicopters. Thanks for being with us again and taking a little bit of time from your very busy schedule to be able to update the industry, everybody that is so excited about this project on where we are on the build of the prototype. So why don't we give it over to you now?
Thanks, Ruben. Thanks, Misha, and welcome, ladies and gentlemen, back to DC1 for another packed update on where we are with the development of HX50. As usual, this evening, the presentation will take the form of a bit of a walk around where we are on the airframe. I'll update you on the engine and the drivetrain. We'll talk about the avionics. I'll add some more stuff on our electrical system development and our power electronics this evening, and we'll finish up with an update of what's going on around this factory here and where we are with our scale up to full-scale production. Let's start with the development of the airframe. So we're currently building fuselage 5 and fuselage 6. Now, one of the benefits of our vertically integrated strategy is that we're developing in parallel all of the production methods and processes at the same time as we're developing the design and the aircraft itself. And what that means is we get the opportunity to bake in a lot of the things that get fed back from production, fed back from tests that we carry out on early production specimens into the design before we freeze the production tooling. And that's exactly what we're doing with fuselage 6 and 7. So one of the major areas that we've enhanced with the fuselage is during the human factors testing, we noticed that we'd got a slight limitation in the upward view angle of the fuselage, and we were able to modify that. We've subsequently gone back, modified the tooling, and we're currently grafting in a modified brow line into the two fuselages that will follow. We're also being able to test out a range of modified production processes for the fuselage that reduce the amount of labor, increase the amount of parallel activities that we can do as we produce these fuselages by working on open tools as long as we possibly can before we bring the whole thing together to produce the structural modelage that you've all got used to seeing. There are some other areas that we're able to bake in as well. As you can imagine, the fuselage is the stickle brick that absolutely everything else attaches to in the aircraft. So as all of these other areas are maturing and their interfaces mature, we're able to capture that and bake that into the production tooling rather than having to compromise on things that were frozen in very early in the design process. So all of those things are going on right now. Fuselage 6 itself, the outer skin of that is now built. All of the foam cores are wrapped, and over the course of the next week we expect to complete the primary shell for fuselage 6, and over the remainder of the month then we'll be grafting in the new brow line and making a few modifications to how the undercarriage fits, ready to accept wheels on that one, and then number 7 will be set up for skids for the December event. So really pleased with how all of that's coming on. Some of the other areas that we've been working on is the development of the general fit and finish. So we've done an awful lot of work on the cabin doors. Doors are far more complicated than you might expect when you're trying to graft flush-fitting doors onto a fuselage that is essentially curved in every direction. It means adjusting the doors on the job is much more complicated than the planar doors that you get on road vehicles, and it's also again an opportunity where we've been able to take a look at how we initially designed the doors. They were initially designed as trapped foam core structures, and we're now looking at an A surface and a tooled B surface construction that allows us to trap a lot of the internal features within the door, and again it allows us to work on both the A surface and the B surface in parallel in production, and both of those parts now get tooled surfaces, so it makes it much easier to produce doors to much tighter tolerances. That makes fitting it on the finished airframes a lot easier to do. All of the tooling approaches for the doors have now been tested. The laminating processes have been developed and tested. We looked extensively at different ways of manufacturing the foam cores before basically deciding that a better way of doing the doors would be to tool both sides and to do them in parts. So all of that work has been going on over the course of the last month, and the guys are currently working on the final production scheme for the doors that allows us to have the tooled A surface, the tooled B surface, the integration of a non-structural door card that allows us to provide that automotive fit and finish to the inside of the interior. We're developing out the locking system that gives us our sort of elegant flush fitting handles on both the door card and on the outside of the door. We've played done a variety of development activities on different sealing strategies for the airframe, for the doors, and we've also looked at packaging the gas struts so that we can hold the doors open. Again, when you look at the doors that I'll show you on the airframe shortly, one of the challenges that we've got on HX50 is because the A pillar is tilted so far back, the door opens out and up, and so it very much needs a gas spring to hold that big door securely open when you're using it. So all of those things are coming together very, very nicely. With the modifications that we've made to the brow line of the fuselage, that obviously passes on inferred modifications to the tooling that we've developed to be able to produce the glazing, certainly the upper glazing for the forward fuselage. So I mentioned last month how the guys had been developing improved tooling strategies to produce optically perfect glazing in-house, both in acrylic and in polycarbonate for the impact resistant windows on the front of the aircraft. We're currently reworking those tools as we speak at the moment to accept the new brow line and to upgrade the surface finish across the full suite of glazing panels that we've got on the aircraft. So all of those things have been going on during the course of the month. The rework that we're doing to the existing prototype tools simply involves using some of the same pasting technology we use for producing the big fuselage patterns to allow us to rework those, and then the latest surface preparation methods in terms of getting that ultra high gloss optical finish that we need to be able to deliver optically perfect windows. So all of those things have been progressing nicely over the course of the last month. We've had a small interruption with the 5-axis machine having a small issue, but that's due to be resolved early next week, and then we should be back up and running with the next set of tools. We're hoping that if we get the full suite of tools completed by the early part of September, within September we should see the first full set of optically perfect glazing panels for HX50 that fit the new modified fuselage. So really pleased with how that's been coming on. One of the key areas that we're trying to push forward in general aviation with HX50 is this idea that HX50 is essentially a flying supercar. It's an aerial grand tourer, and for that we need to deliver levels of perceived quality that traditionally have only been delivered in high-end automotive organizations. Now, that's a very difficult thing to do in an aircraft, because fundamentally you're dealing with composite materials as your base structure, which are quite difficult to finish at the best of times. And then we're dealing with structures that have to be so light that they're inherently very flexible. So getting flexible doors to fit in a flexible fuselage and to maintain the kinds of gap and flush conditions that people have come to expect in premium cars is a very challenging activity. So over the course of the last month, the guys have been working really hard to look at strategies that we can maximize the quality built into the airframe, ensure that the whole surface, the A surface, is delivered perfectly flush, perfectly streamlined, and that we have enough adjustability built into the airframe design that we're able to adjust doors to accommodate the inherent variation that you get in any series production part. So we're working very hard at the moment to engineer quality and perceive quality into the production processes to enable us to deliver these levels of production, perceived quality on every production unit. So there's been a lot of work that might not be obvious as to why you need to do it, but there's lots of really important things going on in these early fuselages that we're baking into fuselage 6 and 7 to make sure that the production units live up to expectations when compared to sort of modern premium cars and supercars. So let's go and have a look at the airframe behind me, and I'll show you some of the things that we've been up to. So as you can imagine, I spend most of my life dealing with the minutiae of tiny little details, making hinges work, locks work, stress analysis work, getting production processes to work. And every once in a while, something happens out here on the shop floor, and it makes you realize, you know, we're getting there. This is really coming together. And one of those moments was when we first got to put the first few glazed panels on, the first couple of doors on, and the physical property that we've got here on the shop floor really started to take shape. We've kind of got used to looking at it here on the shop floor now, but I think you'll all appreciate when you look at it, everything that we said we would deliver in terms of the images that we've provided, the look and feel and quality of the product is being delivered, even on these crude early production demonstrator prototypes that we're producing here. So what we've got here then is the first prototype glazing installed, the first chin windows installed, and we've developed through the strategy for managing all of the panel gaps with the doors, all of the panel gaps with the glazing. We've talked in some of the previous updates about the need to have these blackout obscura bands around the glazing, and those things are there purely because we bond the windows onto the carbon flanges, and so we need to obscure the adhesive behind there to protect the external aesthetic of the aircraft. So these preliminary bands we've just done with a hard edge just because it's easy for us to do that manually. In production, we'll be adding the screen printing process that we showed you previously, and that adds this gradiated dot fade that you're used to seeing on your vehicles at home, just to ease from the harsh black into the transparent area of the screen. And again, it's these little sort of details that really add to the perception of quality that you deliver when you approach the aircraft. One of the other challenges that we've been working with on the prototype aircraft is obviously the doors on aircraft are a lot shallower in section than they are on automotive vehicles, and when you have gaps between panels on cars, they usually sort of back onto a huge shadow gap, so you can't see anything that's behind it. Because our structure sits right behind the doors, it's a much shallower section. We end up having to deal with all sorts of surface treatments and things in there just so that you can't see through to the nuts and bolts of the structure. And it's little details like that that you have to get right to make sure when this is presented in full, it looks right. You'll also notice that we've got the groove underneath the glazing here that receives the chrome signature strip and also part of the signature lighting that goes with the aircraft. We've got the door handles for both external and internal, all in development at the moment. They're being produced as we speak. The door itself, as I said, it opens slightly upwards because of the angle of the A-pillar, and so we have a gas spring installed from the root of the A-pillar up to the base of the door here, well out of the way of foot swing. Now, if you look at the interior of the door here, Milan, what you can see is this early prototype door was based on the original trapped foam construction. So we tool the outside, we put a foam core in, and we lay carbon fiber over the inside. The challenge with this construction, when you then want to trim the inside of the door, is this isn't an accurate surface. This isn't a tooled surface. So we then have all sorts of difficulty in accurately registering the trim panels that need to fit really accurately. And so the move to a tooled B surface on the back of the door makes all of that much, much easier. So those of you that have been looking at the airframe over the course of the last few months might have wondered what these recesses and pockets were. They're there to receive the pantographic hinges that allow us to clear the curvature of the aircraft as we open the doors. And then, as you can see, we've been playing all sorts of tunes on the sealing strategy around the door here, just to get the sealing right, the door to sit right, and the whole door as a system to work properly. So all of that's coming on very nicely. We're really pleased with how that's coming together. One of the other things that we're doing is we've been modifying the brow line. So one of the areas that we identified from the human factors trials is that the aircraft would benefit from rolling this brow line a little bit further up the windscreen. And so we've subsequently developed some a design modification for that, tooled it, and then we've modified, we've produced the first of the insert carbon panels here that will be substituted into fuselage 6 and 7 to prove this out. And all of the glazing's been adapted for that. So we've tooled it and produced the new brow line over the course of the last month as well, so that we can get that into the aircraft. So really pleased to see how this is all coming together. I'll show you in a minute how the rest of the doors are coming together. We've tooled all of the doors now, the A surface for all of the doors. We're doing the final development on the B surface, and then the rest of those can be produced and we can get those onto the prototype and get those things moving as well. So really pleased with how that's coming together. So in addition to the monolage, the main structural part of the fuselage, we talked last month about how we tooled for the first time the tail boom. Now, the first tail boom, in fact the tail boom that sat on the back of the airframe there, was actually made in parts. So as each of the tools from the suite of tools that make the tail boom were produced, we made the part, bonded it together, and that gave us the first tail boom to demonstrate. Subsequently, now we've got a full set of tools, we've been able to go back and produce a structurally representative and manufacturing intent representative tail boom. And this includes the design intent in terms of the structural design of it. It includes all of the processing details for how we wanted to make it. It includes a representative laminate, so the correct carbon plies on the inside and outside, the correct core material to give the boom itself its strength, its integrity, its toughness, and all of the production tooling. And then on top of that, with having a full set of finished production tools for that, we've also got a greatly improved surface finish on that makes it a lot easier to paint. So let's go and have a look at the first of the production intent tail booms. So this is the first structurally representative HX50 tail boom. You'll notice that the surface finish is significantly better on this. So the tooling that we use for this is greatly improved over what we use for the monolage. The processing parameters for curing these are also now significantly refined and getting very close to production intent. And the laminate in there is actually the laminate that we showed you last month, where we've got plies of carbon on the outside, the honeycomb core in the center, and then plies on the interior. And the beauty of all of this is that we get a vast structure capable of taking the large diameter ducted fan, but the thing is incredibly light. So you can actually pick this up with just one hand. So the whole thing currently sits at just under about 15 kilos. And this has still got some structural optimization to go through as well. So it's a very, very large, stiff, but incredibly light structure. So really pleased with how that's come. We've actually built both of those now. So the 2 structural tail booms that we need for the 2 prototypes for December, well, one's here, the other one's down in DC2. So really pleased with how the guys have done with that. The 2 other points just to mention before we go back, we've tooled and completed the covers for the tail rotor drive shaft zone. So on the top of the tail boom, I don't know if you can show it, Milan, we've got an extension of what we call the transmission deck. So this is a flat deck that runs across the entire spine of the helicopter that mounts the engine and then all of the drivetrain components. And so the main rotor, the tail rotor drive shaft sits in pillow block bearings on here into the tail boom there, and then we've got a snubber at the back here just to deal with the rotor dynamics before it pops out in the duct to drive the tail rotor. So those additional parts have been completed. The covering plates for the snubber covers have also been completed and built, and we're now moving on to the horizontal stabilizer to get that tooled and built on there as well. So great progress in terms of the tail boom. So let's talk about the GT50 engine. So we've very much entered an exciting new phase with the GT50 over the course of the last month. You've been watching us do seemingly endless amounts of design optimization in terms of the secondary air system, in terms of the core design of the gas generator and the key rotating parts of the engine. And this has now reached a nice level of maturity where we can literally push all of these things down into manufacture. So with all of the manufacturing processes having been developed in parallel with that design exercise, we're now in a position where the actual parts that are being produced for the actual test engine are underway now. And every few days or so, there's another trickle of parts from downstairs down to Mark. And the guys are a massive push now to get the gas generator for the engine built. They've been on with the engine drivetrain for some time now, and that's all coming together really, really nicely. In addition to the actual prototype build of the engine components, we're also now having to play catch up with the build of a lot of the equipment we need to test the engine, because you can't just have an engine sat there on a tabletop. We need the test equipment to be able to produce that too. So I'll show you shortly what we're doing with some of the test equipment for the first part of the engine that will be tested, the combustor, and I'll also show you later the electrical test bench for the motor generator unit as well. So one of the areas that has been a particular success over the course of the last month has been the development of our turbine blade casting processes. And I can't overstate how important this is to us, because this is an area that's kind of make or break in terms of the viability of delivering a cost-effective turbine engine. So this has been something that we've been working on in the background throughout the entire development program. It was one of the first things I did over a decade ago in proving that we could produce a cost-effective gas turbine engine, and these processes now are all starting to come to fruition. So as we introduced last week, we've got a very novel process for casting these turbine blades, which require an oxygen-free environment, using equipment that doesn't have the same capital cost as the stuff that's been traditionally used by the traditional manufacturers. We've then gone on to cast the first test specimens of the GT50 gas generator turbine blades and also the power turbine blades to the latest designs as well. And what we've done over the course of the last month is not do one iteration, but 3 iterations of that process development to get to a point where we're now making good quality castings that are suitable for testing. So I'll give you a little bit of a demonstration about that just now, but this is crucial to the development of how we make the GT50 engine. So the objective in all of this is essentially to end up with individual turbine blades cast out of ultra high temperature superalloy material. Now this material is really, really awful stuff to cast. You can't cast it in air or oxygen because it reacts and destroys the crystal structure, so you have to put it in an oxygen deprived environment, typically a vacuum. So we've been developing processes, they're conventional investment casting processes, but processes that eliminate the need for the expensive infrastructure to do that. Now, to do that, and to do that rapidly, what you try to do first is essentially cast the blank. So this is essentially, that's the blade that you want to finish up with the fir tree detail in. You don't cast the fir tree detail in, that gets ground in. So we need to cast the blank. So this has just got the stock material on there to be able to produce the fir tree root to hold the disc, hold the blade in the disc. Now, in order to expedite that, we started by using a special rapid prototype material that's designed to burn out of the investment shell, the ceramic shell that we use to cast these things in a furnace. Now, we did that in good faith, and largely because the timescales for getting rapid prototype wax investments were just too long for us to do this quickly. So we tried it with rapid prototype polymers first, and what we found is they didn't burn out of the investment casing well enough. And so when we produced the first set of turbine blades, and what we've got here is a tree of turbine blades. So you start with a feeder at the top, and then some little sprues come off the side of that to give a pathway to get the metal into the cavity that's the shape of your turbine blades. And the problem we had with this is there was so much plastic residue left in the voids after the burnout, that when these things came in contact with the molten metal, they outgassed and left lots of pockets and generally didn't produce a very good casting. So the time saving didn't save us very much time. So by that point, we'd managed to take delivery of the first of the wax blades. Now, these are specifically formulated to burn out. The only downside, as with all rapid prototype materials, there's usually a trade-off. And as you can see, the trade-off with these is they're so brittle that just when you handle them, parts of the blades can come off. So we used these again because they were more readily available than the standard injection molded waxes. And with these ones, we were indeed able to produce good quality cast blanks. Now, ignore the little bits of sort of detritus that's on these blades. We've made no attempt to clean these up. These would usually be shot peened before they're separated off. But this showed that we were able now to produce good quality cast blades. The missing trailing edge there is because it was missing on the fragile wax. So with that now under our belt, we then went on to take delivery of the proper investment waxes, and all of these earlier attempts were just to get things done quickly while we were waiting for the correct materials to come in, which were on a longer lead time. So we've now had a whole batch of these waxes delivered, so we've got enough investments here to be able to make enough blades we've got several boxes of this stuff to make all the blades we need for the test engines. And what you can see here is that we are now making really, really nice castings. So great surface quality. We're burning the stuff out of the investment really nicely. And as soon as we've finished the update for you guys tonight, these things are going off to be chopped up, put under an electron microscope, have all the chemical analysis done on them, have them x-rayed, make sure they're void and defect free. And once we know that's the case, we'll be purchasing this equipment so we can do these in-house, but we'll also be producing the full batch of turbine blades to be able to produce the test turbine rotors. The blades that we will show you later that are currently on the manufacturing build of the engine are rapid prototype ones, so we can't test those. So all of those processes are coming together really nicely. We've shown you previously that we've developed the processes to create the defect-free fir tree roots. And the only other thing, the only other missing element then, is we then have to develop the processes to take delivery of bar stock of the superalloy material and then be able to part this down into precisely weighed measures so that we've got just enough material in each batch to fill these trees. So all of that stuff's been developed. That's coming together really, really nicely. And as soon as we get the results back for these turbine blades, we'll be able to make the full batch of blades for the test engine. So really excited with that. Once we've done the rotating components, the very next step is to start looking at the stator rings. So these are the nozzle guide vanes, and this is our current first stage cooled nozzle guide vane. So this is the part of the engine that comes first after the combustor. It sees the highest temperatures in the engine, and so being able to provide these cooling passages through the blade and out the trailing edge of the blade is vital. So we've got a bunch of casting to development to do on stationary components on the gas path like this, and then also the bigger components like the engine casings and the gearbox casings that are also crucial to the mechanical design of the GT50 and HX50. So really pleased with how all of that stuff's coming along. Okay, so in addition to the turbine blades themselves, obviously the blades reside in a super alloy machine disc. And what we've been showing you over the course of the last couple of months or so is the process development we've been doing to be able to machine the turbine disc and then to be able to cut in the roots of the fir trees that those blades slot into, that withhold the enormous centrifugal loads that the engine sees when it's spinning at 46 to 50,000 RPM at extremely high temperatures. So over the course of the last month or so, the guys have actually been producing the very first turbine disc out of super alloy material for the first test engine. So this might not look much at the moment because it's only part machined, but the guys have essentially finished the parts of the disc that have to receive the fir tree, and then what I'll show you shortly is we've subsequently purchased the wire eroding machine to be able to produce these fir tree roots, as you can see on the slide that I'm showing you on the screen at the moment. So if we just go over to the machine, I'll show you how we produce these roots. So over the course of the last month or so, we've demonstrated using a partner's facilities that when we put the disc within the machine, we can use wire erosion to go in and cut out the profile of the fir tree roots as a replacement process for traditional broaching. This allows us to produce far more accurate fir tree geometry than was previously possible, and it allows us to do it with very minimal capital expenditure. The only challenge was there's an element of process development necessary to ensure that as you spark erode this material away, you don't leave a layer of brittle recast material that would compromise the properties of the disc. We've done that development, we've qualified that process from an engineering point of view internally, and we're just waiting for the guys to get back off holiday over the next week, and then we'll be producing the fir trees in the first gas generator disc. This is the part that will run in the first GT50 engine with our first set of in-house cast turbine blades. So really pleased to see this come together over the next couple of weeks or so. So in addition to the compressor, the turbine disc, the turbine blades, I made you aware over the last couple of months that we've also released the combustor. Now the combustor is a really complicated fabricated structure that sits in the heart of the engine and does the primary mixing of fuel and compressed air to generate the hot gases that the rest of the engine runs on. We've explained previously how this is a series of processes where we buy flat sheet material, we roll this into cylinders, we expand that to be able to hold the dimensions and the cross-sectional profile, and then we use a sophisticated 5-axis laser welding, laser drilling process to be able to put all of those pieces together. Now all of those things are going on at the moment, and we've got the test combustor in production at the moment. So all of the materials for the remaining parts of the combustor fabrication arrived last week, and they've subsequently gone out to a customer that's doing some of the prototype pressing and spinning operations for us, so that we can just get the whole thing done a bit faster. So all of those materials are in stock, and what we're doing now is we're currently making the tooling to enable us to do the expanding. So again, if we just pop over to the forming machines that we've got over here before. So I've demonstrated previously how we roll the profiles between two rollers with the required form on them. That then gives us rings with a little step in them that will slot together to make the combustor. And then the idea after that is they pop onto this machine here, you pull the pin down, and we make these tools here that have got the profile that you want. So the same profile you can see in that disc is present in that tool. And as that is pulled downwards, it stretches this pie slice out and makes the ring perfectly round and to a perfect diameter. So this material for the tooling arrived last week, and what they've currently done, you can see they've made one element of the pie slice tool there, and we've got the next few sections on here on the wire eroding, and that one's just about to be parted off there. So they cut that just before we went on air. That one's got the profile in the outside, and we've just got to go around and make the rest of those, and then we're in a position to make all of the rolled rings that make the outer and the inner annulus of the annular combustor. They'll then be combined with the pressed and spun components, and then we can fabricate it and we're ready to go. So with all of this, there's one other thing that we've done on the combustor that I must tell you about. One of the things that we'll be doing on the prototype combustor to avoid waiting for a very expensive production machine is we'll actually be drilling the 2,500 holes, precision holes in the combustor that are needed to mix the air and the fuel directly on the 5-axis. So just before he went on holiday, Mark did some trials on the super alloy material here that we use to produce the combustor to demonstrate that we can drill these holes in a reasonable time scale using conventional methods rather than needing to use the laser drilling for the combustor. So we've proven that out. So as soon as those things are rolled, we can assemble it and produce the first combustor. So with that coming together, we obviously have to put the facilities together to be able to test it. So the two first tests that we want to do on the GT50 engine, the first one is the starter generator unit, and that involves both the power electronics side and the mechanical side of the starter generator unit. I'll talk about that later. The next test is the first part of the gas generator, and that's the combustor, making sure that we can get the combustor to ignite, making sure that we can maintain stable combustion before we go and put that into the engine, because obviously dismantling and reassembling a whole turbine engine to tweak parameters on the combustor isn't a terribly efficient way of working. So what you can see on the slide there is we've developed a simplified combustion test rig that allows us to combine as many of the core engine components as possible from the combustion system with some simple add-on parts that allow us to run the combustor on a bench, prove we can ignite it, prove we can maintain stable combustion before we embed that deep in the heart of the engine and go on and run the full gas generator. So that rig is just finishing off being designed at the moment, and then again, as the boys return from holiday over the next week or two, we'll be putting that through the production facility here at DC1 to get that built at the same time as the combustor. And providing all of these things stick to the schedule we're working to at the moment, then we're targeting a first run of the combustion system for GT50 in October, and that will be rapidly followed then by the full gas generator unit. So really pleased with the progress made by the engine team and how all of that's coming together. One of the areas that we don't talk a lot about is the electrical system, and that's largely because I'm not much of an electrical engineer. But we've got a very strong electrical engineering and electronic team here now, and the guys have been developing the starter generator, which includes both the mechanical hardware and the power management unit, as well as all the control algorithms, studiously as the engine has matured. Now, the basic configuration for the starter generator was determined and designed a long time ago, as you well know, but obviously as the engine matures, the exact idle speed of the engine, the flight idle speed of the engine, and the operating parameters of the engine mature with it. And so one of the things that we've been doing over the course of the last month is just tuning the design of the starter generator to produce its power at ever so slightly lower speeds, which means slightly lower voltages, slightly higher currents, and adapting that to how the engine wants to run now that we've got the full detail of the engine available to us. And so one of these things one of the features that we've had to update is the fact that at slower speeds the starter gen needs to reject a little bit more heat, and so we've switched from air cooling to liquid cooling. That allows us to keep the size of the overall device nice and small, but it does mean that the casing for the starter generator, and I've got a rapid prototype version of that here. This is to test the cooling passages that are embedded within the casing itself, the manifold areas at either end, and ultimately the heat rejection capability of this. We've subsequently pressure tested that over the course of the last month, just to prove that the integrity of the pressure vessel within this also works. So we're happy that we've got a sort of fuel-cooled starter Gen E that works really nicely. We've now got all the information we need to carry this forward, finalise the electrical optimization of that based on what we now know about the engine, and all of that's coming together really nicely and really quickly. So again, towards the end of October, that sort of time, we should be in a position to test the starter generator over in the engine test, the electrical test cell over there. So really pleased with how that's coming together. Let's go and have a look at how the manufacturing demonstrator is going on for the whole GT50 engine. So the thing that you've got to remember, a lot is made of the fact that we're developing our own gas turbine engine. Now, the clever bits of a gas turbine engine, the compressor, the turbine blades, the fancy castings, and that sort of thing, are only one part of it. What you've got to remember is our real task here is that we're developing an engineered product. We're developing something that has to be made, and something that has to be made to a price to make general aviation healthy again. And so a lot of the work that we do in parallel with the really clever stuff that the guys upstairs do in designing the turbine blades, the compressors, the secondary air systems, the fancy FADEC systems, is we have to make sure that we've developed all of the manufacturing processes properly, and we're not just baking in designs that are just plain hard to make. And so all the way through this development process, we've been developing the manufacturing processes for this in parallel with the actual engine technology itself. And what you can see here in front of me now is essentially we've got a slightly earlier version of the engine drivetrain, but we've got a full engine drivetrain, including the power takeoff from the power turbine, the speed reduction gearbox, the lay shaft that is essentially part of your tail rotor drive shaft. You've got the integrated torque sensors built into the drive shaft on the bottom, and then we've got the bevel gearbox at the front that allows us to bury the whole engine deep inside the back of HX50, out of the way of the wind, in the lowest possible drag installation we can. We've also now combined the gas generator with again, a slightly earlier version of the inlet housing. So on top of this originally was just the air filter. One of the things that we're doing at the moment is grafting an accessory gearbox on here to drive some of the mechanically driven accessories. We've pivoted away from doing directly electrically driven accessories on that. So basically what we're showing here is that the gas generator, particularly now that we've got the casting processes working properly, is viable. We can produce all of that to the quality and the price point we need. We've got the drivetrain. All of the components that you can see here were made as you've seen a sort of chronologue as we've been through the process right here. These casings that you can see on the back, they're currently machined from solid by us. They'll eventually be castings, and then we're just doing a little bit of work on the updated inlet housing to receive the mechanical drives, and then we've got that. The guys in the engine team, as you know, have got the combustor in production at the moment, which sits right here, and then we're just doing some value engineering work on the outer casings and trading off whether we can cast those or whether we're going to have to live with fabrications. But as soon as that's done, that will be following the combustor through the build shop as well. So really pleased with the development of GT50, and rest assured we can build this engine to the quality, to the life, and to the price. Okay, some of the other areas that I haven't updated you on very much recently, purely because it seems like more of the same. but is our drivetrain production process at the moment. So we spend a lot of time documenting and demonstrating how we produce high quality aerospace grade gears for the main rotor transmission, the engine drivetrain, the tail rotor gearbox. But one of the things that you don't really see and is not that exciting to report is the 30 different steps that have to be developed to produce those gears to the quality and then to be able to inspect and qualify them for an aerospace application. And one of the things that Mark has been tirelessly doing over the course of the last few months, but has really come to a head in the space of this month, is bringing all of those things together. So we're now in a position where we're producing the first 3 drivetrains, and the final of those ones will be the test drivetrain and the first flight drivetrain. And I'll show you when we do the production walk around the sheer volume of components that we've now got lying around the facility that are going into those gearboxes. So in summary, we've now mastered the gear cutting processes. We've got the heat treatment processes under control to our specifications. We're just doing the shot peening development processes at the moment. We've developed all of the measuring and the quality control, and we've just put the first batch of gears through the final non-destructive testing elements of our process flow to deliver flight-worthy gears. And so all of that has come together to enable us to get the full HX50 and GT50 drivetrain into production in our own facilities. So really pleased with how all of that's coming together. And like I say, I'll show you a little bit more about what that actually looks like on the ground as we do the walk around in a little while. Another area that we've been developing over the course of the last month or two is the Sprag clutch, and also where the Sprag clutch sits in the whole drivetrain. So we did a design for maintenance review a little while ago, and we'd reported that the feedback was we needed to move the Sprag clutch from the front half of the engine drivetrain to right at the back, just where the tail rotor drive picks up. That work has been completed, and we've also now produced the very first demonstrator Sprag clutch as well. So the housing, all of the interfaces that go into the drivetrain, ready for the machines for the end of the year. So if we just pop over here for a second, then what you can see here is the very first HX50 Sprag clutch assembly. So this is the outer housing that plugs into our gearbox. Sorry, this is the drive shaft that plugs into the gearbox, and this is the output housing here. And as you can see, the shaft is free to run in one direction and lock solid in the other, and that's due to the Sprag clutch assembly that sits in the middle there. And these are just a bunch of tapered rollers that when you roll it run one way, they move closer to the center, and when you roll it the other way, they increase the diameter to allow the thing to roll freely. So really pleased with how that's come together. Similarly, as I'll talk about in a second, you've seen our rotor brake assembly previously. This was always mounted on the input drive shaft to the main rotor transmission, and again, part of the design for maintenance feedback loop that we've been through is that we need to move this assembly further away from the input to the main rotor gearbox, purely to avoid the heat that's generated in the brake disc from cooking the oil seals on the inlet to the main rotor gearbox. So we haven't finished the move of this yet, but we're currently moving this, and again, this will sit right next to the Sprag clutch at the back of the engine, right next to where the tail rotor drive picks up. So pleased with how that's coming along also. So yeah, as you can see here in the little figure at the top, it just shows the current location of the rotor brake, very conventionally tucked up at the input to the main rotor gearbox. As that brake heats up when you slow your main rotor down, that can damage the seals, and so the plan is just to drop that down to the heat insulated area at the back of the engine speed reduction gearbox. So that work's currently ongoing, and we should be able to report that an update on that next month. One of the areas that we get a lot of questions about is the main rotor system for HX50, and the main rotor, in terms of the aerodynamic design, the blade design, has been stable for a very, very long time, say 2 years or so. The main rotor hub itself is central to the performance and the handling qualities of the aircraft, and we've been through a range of iterations of this in order to get just the right balance between a compact and an aerodynamic design but using conventional low-risk mechanical elements to this. We don't need to be at the forefront of technology for the main rotor system. What we need is absolute reliability and benign handling qualities. So our rotor system is very much, again, a greatest hits album of all of the things that have been shown to work really well over the decades gone by. So we use composite flexures that handle your flapping and your feathering movement, a cuff arrangement, as you will have seen on a number of previous helicopters, and then elastomeric lag dampers. There are a couple of clever details with the rotor head that we won't declare until a lot later in the program. The way we do our lag damping is quite intelligent, and obviously the way that we fare this whole arrangement into the aerodynamic fairing of the aircraft is also very clever. So I've left those features out for now. In terms of the swash plate, in terms of the flight control arrangement, again, it's all very conventional. You've got a conventional swash plate mechanism. We've got the typical pitch and roll seesaw beams, and then a collective jack beam that handle the inputs to the non-rotating swash plate, and all of that sits on the top of the main rotor gearbox as it would on any other helicopter. So there's nothing in there for people to be concerned about. Again, it's an exercise in abject reliability, total reliability, and working with things that are known and working with things that we know we can develop to meet the life and the safety and handling objectives for the aircraft. So pleased with how that's coming on. There's a bunch of work going on at the moment to optimize the structural dynamics of the blades, and then they too will be released for tooling. So one of the other areas that we don't talk about one of the next area I'll update you on is the DigiCockpit. So as I mentioned previously, we've now got the system operating on target hardware. And we showed you the exploded board of the target hardware that allows us to integrate these various components last month. Since then, we've managed to get the target hardware driving the target screen via the correct communications protocol. So we've now got the PFD screen running on the actual target screen with the actual target hardware, and the guys are going through and integrating the audio panel, the transponder, the comm, the GPS. All of those applications are working off target and are now being ported to target to get the whole system singing together. The performance testing that we introduced last month is also ongoing, but one of the interesting things that the guys have done over the course of this month from a customer perspective is they're starting to look at now some of the other splash screens and some of the other graphical details that will be presented during startup and during the various phases of the operation of the DigiCockpit. So one new area of the UI development that's received a lot of attention over the course of this month is the user interface and the user experience for the IPI, the little center touchscreen in the center of the armrest that controls all of the things that you need to input into your helicopter. So the original concept for this looked quite nice, but the menu structure was a little bit clunky. Every time you went into something, you then had to do what you want and then back out of a menu layer. And so one of the things that the guys have been investigating over the course of the last month is whether they can reduce all of that down to a simplified menu structure with a single home screen, where all of the things that you need to get to are just presented cleanly and elegantly. And what you can see on the screen there is some work in progress of how they're developing that. So you've still got your audio panel controls at the top, you've got a palette of comm menus to put your frequencies in and your radio controls, and then you've got your barometrics and your autopilot controls and your transponder all permanently resident on the home page. So it's just one touch to then get to an area where the PUC can control all of that for you. So really pleased with how that's coming on. There'll be a lot more on that and a lot more on the MFD as we go from here towards the full unveil at Christmas. In addition to the software development and the user interface development, we're obviously having to focus now on the development of the physical aspects of the instrument console, both in the main console and in the roof console as well. So two of the areas that we've been focusing on has been the start panel, so the backlit switch deck that controls all of your startup controls, your fuel controls, your master battery and all of those things, how you do the backlighting, how you package the high integrity switch gear that we need, and how we dress that so it sits in the console as we need it. We've also been doing some packaging exercises for the PCBs and the switches, and getting the perceived quality elements right for the stick head. So the image that you can see on the bottom of the screen there is the stick head that sits in the cyclic and the collective. That one's the cyclic one that packages the springs and the switches and all the other good stuff that makes all that functionality work properly. We're also now starting to get serious about how exactly we want the iPad mounting to work in the center of the panel, and we've also been doing some practical work on the integration of the how we develop the finishes that we want on certain trim parts of the panel. So if we just pop over to the DigiCockpit for a second, then you'll all be familiar with the IPI interface here. So the screens, everything that you need to do is on the IPI. We've always given people the option to type transponder codes and frequencies in using a touchpad, but the idea was always that you could use the PUC to control that. Now, one of the areas that we had to be really careful about was that when you're flying and your arm's on the armrest and the collective's coming up and down, we didn't want your hand to be inadvertently interacting with the PUC. So part of the design was to create a little guard for the PUC. And one of the things that we've been prototyping over the course of the last week is the first of it's one of the trim options, and the first of the surfaces that we're going to integrate the PUC into the cockpit with. So there's two purposes for this. It's to test the sort of ergonomic aspects of using the PUC, and one of the things that all the guys have picked up actually is that's still a little bit restrictive, so we need to just tweak this profile a little bit. But the other thing is looking at some of the ways that we can generate the piano black finish that the original design of the DigiCockpit used. So how we can produce this in a way that's going to stand up to 50 years of service. So we've been doing some trials on direct machined acrylic for that purpose. Obviously it would be injection molded or molded in practice, but in terms of the early ones we can machine those, and those trials have come out very well. We do get a lot of feedback that not everybody likes piano black. It's obviously trim, color schemes, palettes of materials are very much subjective and very dependent on your experience in life, where you're from in the world, and so there will be a range of options for these sorts of things. But right now we're focused on just getting the base thing working, all of the key parameters sorted, so that we can get this thing built and flying as fast as we can. But that's one of the areas of trim development that the guys have been looking at this week, ahead of putting a full instrument console together, both for the center console and the roof console. Let's go back. Okay, so let's talk about engineering the electrical and electronic elements of GT50, of HX50 and GT50. So as I mentioned, one of the novel aspects of the GT50 engine is the fact that we use a direct drive starter generator. So our starter generator spins at the same speed as the gas generator rotor, so 46,000 RPM nominally. Now at that speed we generate very high voltage, very high frequency AC. Okay, and the aircraft runs on 28 volts DC. So what we've got to do is develop the power electronics to convert the electricity as it's generated by this compact, lightweight, efficient electrical machine into stuff that we can use on the aircraft. And to do that we need a suite of power electronics. Now the power electronics involve the control algorithms that receive whatever the starter generator produces and then chop it up and turn it into the right voltage DC. It includes the electronic components that are needed to physically do that stuff, and then also the physical components that put all of that together. And one of the things that Zhenyu has been leading is developing what we call our power management unit. And that's the unit that does all of those things. He's developed the control algorithms, he's currently developing the AC to DC conversion, and then we'll do the DC to DC voltage conversion as the last step in that. And to do all of that, not only have we had to develop all of the equipment to do it, we've also had to develop the test facilities to be able to test the components as we produce them. And what we've got over there on the electrical test bench, which I'll show you in a second, is the facilities that allow us to drive and test the starter motor, drive and test the generator, and then downscale the power electronics to something ultra light and compact to actually go onto the aircraft. So let's go over and have a quick look at the electrical test bench. So I know you're all very used to me talking about composites and gears and engines and aerodynamics and that sort of stuff. The truth is that without all of the software and without all of the electronic and electrical components, HX50 would just be an ornament. And so although this stuff is not natural stomping ground for aeronautical engineers, it's really, really important to what we're doing. So what we've got here is essentially a bunch of mathematical formulas that chop up this three-phase high-frequency signal that the starter generator, that the generator produces when it's running, and then processes that into usable electricity. Now what we've got here is our control algorithms developed right here at Hill, embedded on an off-the-shelf power converter. So this is just a bigger industrial version of what we need to put on the aircraft to run the starter generator. So our algorithms are now working and delivering the levels of power conditioning that we require. And what Zhenyu's focused on at the moment is developing the PCBs to miniaturize all of this and get the weight and the size down, the efficiency up, so that we can package that on the aircraft. And what we can do with all of these facilities here, this unit itself with all of the control algorithms is able to drive that first starter generator when we produce it. So this will allow us to drive the starter generator to start the test engine, and then this will also allow us to run the generator with the engine and generate electricity. So all of that stuff is now here in place, and the final piece of the puzzle that you can just see down here is the power source and then the load bank that we need to receive all of the power that's generated by the starter generator while we're testing and developing it. So all of these things have been implemented over the course of the last month. You've seen us develop the avionics test bench. Now we've got the power electronics and the electronics test bench to bring those parts of the electrical system together to make this aircraft fly. Let's go back. So one of the last things to update you on then from around the company is just a quick update on what we've been producing around the business over the course of the last month or so. So as we've talked about, we've got Fuselage 6 in production, which is the wheeled demonstrator we're intending to show at the end of the year. Fuselage 7 will be following that shortly. We've now produced both of the tail booms. The A-surface tools have all been produced for the 4 cabin doors and the 2 baggage bay doors. The cover for the top of the tail boom has been produced along with the cowling panels, which just leaves us with the upper fuselage and the latest generation of the seat tools to produce in there. On top of that, we've also been busy here at DC1. There's been plenty of gear production, as you'd be aware, lots of turbine components starting to come together. But one of the things that you won't have seen very much of yet is we're now starting to amass quite a significant number of components for the wheeled undercarriage system. So we've got some of the mounting components, we've got the brake calipers, we've got the upper parts of the main undercarriage oleos, we've got the fork here for the nose wheel, we've got some stub axles over there, We've got plenty of anti-rotation links and scissor links and things lying around now as well. So all of these things are coming together really nicely. We've got a bunch of internal components for oleos and pivots and things here. A mixture of these, the majority of these things are built by us. There is some stuff that we're doing outside at the moment just to speed the process up. When I spoke to you earlier about the drivetrain components that we're producing, to give you the sort of scale of manufacturing that's going on here in terms of precision components, this is a batch of gears for the first 3 engine drivetrains and some of the components of the main rotor gearbox that have just come back from some of the inspection processes that are required as part of our 30-step process for manufacturing gears. So this stuff I think has just come back from NDT and is now ready to be finished machined, ready to be made up into the first 3 engine drivetrains. And the intention is that one of those, the third one of those, will be the flight drivetrain. This, believe it or not, is how main rotor gearboxes, well, prototype main rotor gearboxes start life. So we've just had this stock delivered, ready to make 3 more sets of main rotor gearbox casings. In production, we'll be casting these, but for the early functional demonstrators, for the early test articles where we're testing lubrication, run dry, it's just convenient for us to be able to manufacture those from solid because we can do it a lot quicker. We've just taken a delivery of a bunch more material for some of the bigger gears in the engine, and there's the stock material for 3 more rotor masts down there as well. And over the course of the last couple of weeks, we've been producing the first set of wheels for the HX50. So there's the first nose wheel, is the first main wheel with a nice bit of hill bling in the center of it. And then with these main wheels, as you can imagine, on the back of them, we have to have a floating integrated brake disc as well. So the brake disc lives in there, caliper is retained in there, and then we've got some of the anti-rotation and scissor links and things that we've been building there as well. So what's your step, Josh? From across the program, both DC2, DC3, and right here at DC1, everybody's flat out producing the components to get these first demonstration aircraft together. So really pleased with progress from across the program. Okay, a quick update then in terms of the factory. As I reported last month, we'd been asked to do some additional noise assessments for the Cresswell site. This work has now been completed. As I think I mentioned last month, we've been using one of the UK's leading authorities on aircraft noise, a guy that looks after a lot of the big airports in the country. We've optimized our flight corridors, we've optimized our aircraft movements, and we're expecting the noise levels from that work to show that all of the impact is now below the level for which there's any measurable impact on human health. So we've put ourselves in the best possible position to get this planning permission awarded. So pleased with the progress on that front. And then in other news, it's been another strong month in terms of sales. We currently stand at 902 aircraft sales with 733 X's, 169 C's, and I think it's 62 countries. Ruben and Misha will update me when we talk in a moment. But sales remain to be extremely strong, and of course, every week when we demonstrate further progress and more major steps in the program, it brings more people in. So there's never been a better time to come and join what we're doing here to General Aviation. So thank you very much for your time and attention, and I'd be happy to answer any of your questions. Thank you.
Wow, what a phenomenal update, Jason. One more. And what is incredible about these updates, Misha, is that it's really exponential. It's really exponential, the rate of development that we're witnessing actually in real time. And this is something special about Hill that is unique, that we update almost every single month. These updates have been happening now, about more than 20, and it has been phenomenal actually to follow the journey as it's happening. So we have been receiving a lot of questions, Jason. Be ready for them. We're going to be staying here for a little bit of a time because there's a lot to be answered. Really good, great questions. I'm going to start with the first one, and actually I'm going to also motivate everybody to put those questions in on the chat. So we're receiving them and put it in sequence. And we're going to be seeing how much we can actually answer with the time that we have. Let's see. The first one is from Drew, Jason. It says, can you provide more information on the planned rollout timing of the flight manuals, the specs, limits, and maintenance information, etc.?
In reality, those things can't be done in anger until we've got through the flight testing program. So they'll follow very quickly after we've demonstrated the flight performance. Although we've got a very clear idea of what the structure of those documents looks like. We've got a very clear idea of what the calculated performance charts look like. But until we've got the hard data, there's really no point in investing any more time in that. So I would expect the earliest you would see those, it's literally just before we enter production. So I'd expect it maybe 2 or 3 months before we go into production. No sooner than that, because we just don't have the technical resources available to spend time on that at the moment.
Okay, excellent. Next question is also from Drew, and it deals with insurance. So he says, will an HX50 owner's policy cover him to fly in another HX50 owner's aircraft? He says he can think of some different situations and advantages for that. So when you're hangaring in a shared hangar, 2 aircrafts, different owners in the same hangar, possibly when one's down for maintenance, the other one could fly, or if you're doing a group flight, possibly be able to fly the other person's machine. So do you have any input on that, Jason?
Yeah, that is absolutely my plan. I haven't done it yet, but that's absolutely my plan. I want the insurance to be an enabler rather than a blocker. And so the more flexibility we can provide to enable our community to function as a community, the better it will be for everybody. So the insurance will be readily available, and it will seek to allow people to use the network around the world.
Excellent. Still in insurance, just following up on that, has Hill coordinated with any insurance companies to ease the process? Have there any contacts been made on that?
Yes. Yeah, we've been talking to insurance companies for about 18 months or so. So yes, we have.
More to come on that, and there's a lot of good details on that program that is coming and being discussing with some major players, right, Jason? So that it's going to be some good news coming in, and that relationship is being nurtured as we speak, correct?
Absolutely.
Yes. Good.
We can't say more of that at this stage, so go ahead.
Yeah, with some of these things, I think things to do with the factory, things to do with planning permission, things to do with ongoing commercial negotiations. There's only so much I can say publicly without prejudicing the discussion. So my position on insurance has never changed. I want it to be affordable because we make money by selling more helicopters. So anything that's a barrier to people feeling they can afford to buy a helicopter is an enemy to me. And so cost-effective insurance, subscription-based cost-effective maintenance, and then making that as flexible as possible is really important to what we're doing. But there's a limit to what I can say until we've actually done the deal, and put the provision in place.
Excellent. A question on flight training options. What flight training options will be available at the facility for the owners as part of their build out in terms of hours per machine, and what sort of ground maintenance practice syllabus is planned?
It's a good question. It's not fully detailed yet, is the truth. Again, our organization is very focused on building helicopters and then developing, testing and refining what we're doing here. Fundamentally, we will end up providing flight training at the factory as part of our safety course on an ongoing basis. In the short term, we'll be making sure that owners and instructors and examiners get type rated as fast as possible. So we'll be making a significant number of our own aircraft available to people at the factory or at our sites to enable us to get support for pilots out there around the world as soon as possible. Again, I don't want the availability of instructors, of safety pilots, or of examiners to become a bottleneck to our progress. So every machine's sold with a type rating for an owner, so they've got that. And beyond that, we haven't really mapped anything out. So we have a 0 series of aircraft that will be built before production starts as part of our production ramp up, and we'll be using those aircraft to handle the training and development needs of early adopters.
All right. Next question is what controls are on the Collective? What touchscreen features are on the main display?
So on the Collective, you've got a fly and idle button. So that's your primary FADEC controller. So when you start the aircraft up, it would normally be in idle. The FADEC will then bring the engine up to operating speed to ground idle. You flick that, and then it goes up to 100%. Your RPM's governed for you. Dead simple. And then the other two switches you've got on the Collective are your landing lights and your hydraulics off. There's also a trigger on the Collective that is tied to how the autopilot functions work. So generally, the Collective will have a trigger. So to move the Collective, you pull the trigger. When you release the trigger, it'll hold the Collective where it is. So it's a slightly more sophisticated version of what you'd be used to, similar to what's been done in aircraft like the S-76 before now. And then, sorry, you asked about on the main screen.
On the main display, yeah. Yes.
So on the main screen is predominantly a display. Okay, so it provides all of your primary flight information. One of the functions that we've built into that is that you've got the autopilot modes in the bottom corner. So you can turn on your stability augmentation, altitude hold, heading hold, speed hold, and navigation hold. For the 4-axis version, there's a yaw mode as well. And then on top of that, you've got your transponder and your comm radios at the top. And then if you touch the big gauges, what that tends to do is just pre-select the relevant page on the IPI so that the PUC will change what you want it to. So the controls on the screens, although they are touch screens, the main purpose of those in flight is to provide information rather than you trying to reach out with your arm bouncing up and down while you're flying. All of the input should go in through the IPI.
Okay, very good. Next question is from the very famous Chuck Aaron. People will know Chuck Aaron from Red Bull.
Hello, Chuck.
With the aerobatics. And his question is revolving around the engine. So you gave a really good update on the engine during your presentation, so I don't think we need to recover that. But how is the engine coming, he says, and is it running yet? So do you want to maybe just give a bit of a summary from where we are today until the helicopter flies? What does that test program look like?
Yeah, so the engine's coming on really well. As I say, when you're developing a new engine manufacturing company from scratch, all the real work is working out designing it in the first place, working out how you're going to make it, putting all of that infrastructure in place, and once you've done that, you've got a thing that you can then test and develop and produce in volume. So from where we are today, the first two things that will be tested are the starter generator to prove that we can start the engine, and then when the engine's running to prove that we can generate electricity, and that will be done on the test bench over there that I've just shown you. The next test that we'll do, is the combustion system. So combustors are notoriously difficult to design, and there's lots of gotchas that you can fall into. And of course, we're having to develop our combustor to run on conventional jet fuel and synthetic fuel, biofuels, cellulose-based fuels, all these sorts of things, so that we can provide carbon neutrality in the immediate term. And so that's the next thing. That will be put on that little test rig that I just shown you, and we'll prove that we can ignite, we'll prove that we can sustain flame, and we'll just optimize the combustion system before we build up the entire gas generator module. So that's the inlet housing, the compressor, the diffuser, the combustor, the power turbine, the interduct. That will then have a big nozzle stuck on the back of it to represent the power turbine, and we can develop the whole gas generator throughout its entire operating range using that method. Once we've got that working, we can then add to that the power turbine and plug that out into the engine drivetrain. What I should say is, in parallel with doing the gas generator testing, we'll have the engine drivetrain that I've just shown you in bits over there on the floor running on a bench, just to prove that that mechanical system can absorb all of that power from the power turbine without making metal and causing us problems. Once we've got the whole engine running together, then we can go and map out all of the performance of the engine, clear enough flight and enough cycles for us to be able to go off and do flight testing. While they're off flight testing, we'll have an engine or a series of engines on test benches just running up the hours to clear the service life. And the full service life will be still clearing when we're into production, like it is on many other aircraft.
Very good. Lars has a question about skid version. What is the ground clearance, and does technical drawings exist at this point for the skid version?
Yeah, technical drawings exist for wheels and skids. They're on the customer app, and we can share them with anybody that's interested. I think they're on the website, actually, aren't they? The clearances. The clearance from the ground is about 350 millimeters, but I'd have to check the drawing for the exact values. It is the same for both variants. But it's, so what's that in, I think it's about 14 inches, something like that, 14, 15 inches, or 350 millimeters. But I'd have to check off the top of my head. It's been a long time since I looked at that.
Okay,
I could just go and measure it.
It's on the website. That's good.
Yeah.
Yeah, it's on the website, you're right. Yeah, there's technical information there. Gonzalo is asking about, would it be possible to use diesel fuel?
So we get asked this question a lot. You know, fundamentally, it costs us an awful lot of money to qualify fuels for long-term use in the engine, because the problems that you get with the complex chemistry of combusting various different fuels manifests itself in terms of hot corrosion problems, and little quirky characteristics of how the combustion system in the engine at large works. And so the only plans we have at the moment is to qualify the engine for conventional jet fuels that are available around the world, and for biofuels, so that we can deliver carbon neutrality. In terms of diesel, if there is a big enough demand from the customer base for it, we would look at it, because fundamentally I don't see any reason why we couldn't make the engine run on it. But in terms of being able to make it an approved, safe and insurable fuel, we would have to do a bunch of long-term testing, which means running engines for thousands of hours. And there's a big cost to that if it's only one or two people that want it. So it's possible. There's no plan to do it unless there's a large enough proportion of the customer base need it.
Yeah, we can just ask, bring the fuel, we can test it, right? Bring the trucks.
Yeah,
we can do
yeah,
that
by all means. Yeah. You provide the fuel, I'll burn it for you.
Yes. Drew is asking a very practical question, is when am I going to be notified about the upcoming payments? I want to have this in my planning for serial number 438 is for him. And he's asking about the planning of when are you going to be calling the second payment?
Yeah, we'll call the second payment as soon as essentially two conditions are met. We need to be 12 months away from production, and we need to have the aircraft flying, essentially. So those are the two conditions that we've always said. We're not going to call those payments until we've met those milestones. So, and then the payments will be called based on the production schedule thereafter. So yeah, you can expect the further announcements on that shortly as we get closer to it.
You're very close to that new information coming out.
Yes, exactly. Next question is from Michael, but I think you're going to think it's coming from Dino. So this time it's not actually coming from Dino. He says, now that you've built 7 carbon fiber hulls, are you more confident in the ability of offering bare carbon fiber as an exterior option? If not the whole hull, are there partial sections that would be likely to have as an option to be exposed?
So in terms of laminating it and making pretty carbon fiber parts, I'm really confident in that. We've got some amazing laminators, and some of the parts that we make down at DC2 are gorgeous, but that's not the problem. The problem is that fuselage works for a living. It's the structure. And if we leave the carbon fiber exposed, the resins would be subject to UV degradation over time and would lose their mechanical integrity. So unfortunately, in terms of the structural parts, they would always have to be painted to protect them. In terms of non-structural or cosmetic parts, then there are possibilities there. But like I say, we're laser focused on making the first one with a simple set of options working. Then we'll roll out lots of trimmings and things for people after. The project is vast enough as it is. We need to stay focused and cut our cloth to getting a machine that flies first.
David is asking, can you cover a little bit of your thinking in choosing a Genstern style tail as opposed to a Notar?
In terms of a ducted fan tail rotor, the main reason for that is that fundamentally they provide a lot of protection to inexperienced pilots, but without the complexity and the significant non-linearity of the Notar system. The Notar system isn't any simpler than a ducted fan. It's just the fans somewhere else, and then you've got the big swivelly can on the end, and there's lots of characteristics that make that quite difficult to engineer. I don't see a weight saving, I don't see a complexity saving. So for me, for my customer base, we can engineer the acoustic properties of a ducted fan very nicely. It's a nice safe solution. It looks nice on the aircraft. It has lots of authority, and the big vertical fin has lots of benefits for us in terms of the handling qualities as well. So for me, at the moment, that seems like the best option for helicopters in this size and weight class.
Okay. Excellent. Next question is coming from Kenneth. And he says, could you give a little bit of an update or comment if you're planning to start deliveries of helicopters sort of end of 2024, beginning of 2025? We haven't had we don't have the start on a factory yet. So how do you see basically building a factory, equipping it, staffing it, getting everybody trained to be able to start delivering in that time frame?
So again, I've got to be very careful with what I say here because there's an awful lot of stuff going on behind the scenes. All I can say is that is in hand. So in terms of the equipment, there's very few pieces of equipment now that are on lead times that are problematic to us. The lead times have collapsed right back down to something that's much more manageable for us. In terms of staffing up, we are already starting that process in terms of the guys that are employed in DC 1, 2 and 3 form the people that will train the new recruits in the processes that they developed right here. In terms of the building itself, we have an internal impending deadline upon which we, if we don't get an answer that we need to do something else. But there are lots of ways that we can put this thing into production quickly. So just bear with me while I deal with all the commercial stuff behind the scenes to make that work for you. And if you really want to know, just phone me privately and I'll tell you.
There you go, Kenneth. You have a little bit of an invitation there. All right. What about airspeed? Where are we standing about airspeed, Jason? A bit of an open question here.
I'm robust that we will deliver 140 knots at least, as promised.
At least, like that.
Drag
looks.
looks.
Next one. Let's go.
Drag looks good. Power looks great. So yeah, we're in good shape for speed.
And lift capacity.
And second part of that question. Yeah, lift capacity.
Lift capacity is amazing. It's significantly more than advertised. Okay. One of the things that one of the last things that we did, I don't know if anybody clocked it on the rotor head slide, but we've slightly increased the chord on the blades to protect the forward flight performance at the higher altitudes. Because we've got some customers that operate at higher density altitude, and that's given us a big boost in terms of lift capacity at lower altitude. So, yeah, you're not going to struggle to get off the ground.
Excellent. Robert's asking. He says he's seen some concerns online about the tail rotor looking oversized. Or sorry, no, not oversized, undersized. Can you shed any light on that?
It's fine. the tail rotor can maintain directional control at max gross weight in an out of ground effect hover at 10,000 feet on an ISA plus 15 day with a 35 knot wind from any direction. So the tail rotor's fine.
Right.
Now, there is always some quirks when you put the tail rotor in the fuselage and you test it for real, but there are also some well-known fixes for those quirks. So I've got no doubt it'll put up a little bit of a fight when we fly it, but we know how to fix those problems also. So the tail rotor will be fine.
Michael is asking, a lot of the newer, smaller airplanes like the Cirrus have a side stick yoke small joystick. With the innovation of this collective, did you consider the possibility of a more joystick-style cyclic?
The problem is, with helicopters of this size, the flight control loads are so high when you have a hydraulic failure that you need the lever of a full-length cyclic to be able to maintain attitude control. With a little side stick, it would be really difficult to generate the roll control that you need. You could probably make it work in pitch, even though that too would be quite difficult with the limited range of travel. But the only way I can see that working is if you went to dual hydraulics and did away with the hydraulic failure case, or you went fly-by-wire. Neither of those things I'm prepared to do at the moment, so the best choice for a helicopter of this type and class is a conventional mechanical flight control system with simplex hydraulics, and then that will be scaled up to dual hydraulics for the IFR version later on.
Good. Steve is asking, I realize that cooling the starter generator with fuel is an implementation done on other aircrafts. The notion of running fuel around a hot starter generator is still worrisome to me. What risks and mitigations are there around this approach?
Lots and lots. Obviously, you don't want to throw fuel into the inlet of your engine. That would cause you a problem. Again, there's lots of detailed design around the containment of the fuel, around the sealing of the fuel, to make sure that that's an extremely remote case. And then the engine being FADEC controlled has got a lot of sensors on board to monitor its health and make sure those sorts of things don't become a problem. So we've got a range of safety measures. To be quite honest, beyond the basic performance parameters of this and getting this to work, there's a bunch of detailed stuff that's still yet to be done on this, but there's no point in doing that until you've got the size absolutely nailed, you've got it tested and working properly on the bench, and then we can come back and deal with the nuanced details of the finer elements of the safety case. At the moment, we've just got to make it work. But don't worry, it is done all the time, and the guy that runs that project for me is the most risk-averse person you'll ever meet. So he's not going to accept anything that isn't absolutely robust.
Bill has a question that leads to a suggestion on the product. I would like to know if it's possible to build into the 4-axis autopilot a safe return button with, in an emergency situation, should something happen to the pilot, any passenger can activate the safe return in the form of a red button, similar to the one on Cirrus Vision 50 small jet. This will automatically land the aircraft at the nearest and safest area available and notify emergency response authority in that country or area.
Yes. Yeah, I've always said that that's possible. I've always said that we want to do that. Again, we're focused on minimum viable product at the moment. That, from our point of view, is predominantly, if you have the 4-axis system, it's predominantly a software issue, and we'll follow up with that in due course. So yeah, I definitely want that functionality. It's a no-brainer. There's a bunch of things with the 4-axis autopilot that are exciting to me. There's a whole host of handling qualities refinements we can do. There's RPM, automatic RPM control in auto rotation, automatic entry into auto rotation, and then safe return home, safe 180-degree turns in the event of inadvertent IMC. There's a whole bunch of stuff you can do. But all of that comes with a bunch of legal ramifications and a bunch of certification ramifications that you've then got to go and do in 62, 63 countries. So we have to roll that stuff out progressively, otherwise we'll just drown in the scale of the project.
Okay. Good. And 64 countries. Michael is asking...
that makes me feel better.
I think there's a misunderstanding about the way that the flight controls are connected to the rotor head and so forth. So he says, since the helicopter is fly-by-wire, will the cyclic movement throw sensitivity be adjustable? So maybe can you give a little bit of explanation that they're not fly-by-wire? I did see a question a little bit later on. Somebody was asking about the flexible push-pull rods. So maybe just give a little bit of description on that as related to the H145, which is what the other question is related to.
Yeah, so the aircraft is not fly-by-wire. It is not a digital flight control system. It's a conventional mechanical flight control system. The only difference being, rather than having a bunch of bell cranks and push-pull tubes and things like that, at the bottom of the cyclic in the front of the fuselage, we have a series of push-pull bearing cables. So these are cables with a stainless steel blade down the center and ball bearings either side of the blade, surrounded in a track that's wrapped in an environmentally sealed cable. And then that cable is strapped to the undercarriage wheel well. It goes round the nose, up the inside of the nose beam, through the roof, and emerges out by the main rotor gearbox, where it picks up on conventional bell cranks to turn the motion through 90 degrees and put the input into the hydraulic servos. So they're just mechanical. They're mechanical cables, they're mechanical push-pull cables. And that applies to the cyclic, the collective, and the tail rotor pedals. The tail rotor pedals cable runs directly under the belly and then pops up into the bottom of the inside of the tail boom. So it's conventional, other than we use these cables in the place of push-pull tubes that need bell cranks, that need bearings, that make funny noises, that vibrate, that are exposed to the elements, that can corrode, that have a large part count. All of that's eliminated, and we put some cables that strap straight to the airframe, are very quick to fit, are very reliable, and have a beautiful silky smooth motion in both directions. So yeah, we like those a lot. They're great.
Fantastic. Next, we have two questions. I can answer the first one, easy one, and then the second one you can go ahead, Jason. The first one is about the simulator status. When can we have the simulator for Flight Simulator available, Microsoft Flight Simulator? I just checked with the team, and it's in development, and we're targeting Q1 next year. So Q1 of 2024, we're targeting as a date of release for the Microsoft Simulator of the HS50. It's going to be a lot of fun. Have that first contact with the real flying data inside that simulator. Next one is from Jeffrey, and he says, do the doors have a quick release pin for emergency exiting?
No, they don't at the moment, but it's something that we are looking at. So the doors are removable. The gas spring and the two banana hinges have pins that allow you to lift it off in the same way as you would other helicopters. We're looking at a range of jettison options, not necessarily for the door, probably for the windows. And if you captured the scale of the windows, certainly in the pilot seat, they're huge, and the window sill line is below your thighs anyway. So it would be very easy to escape through those.
Very good. And Kevin is asking a good question. We actually had a discussion about that earlier in the week, last week actually. I'm assuming there is a radar altimeter for the 4-axis autopilot. Will it be shielded from the 5G cellular interference that we're dealing with all across the US right now? Will the cockpit lighting, panel, etc., be night vision goggle NVG compatible?
So in terms of the shielding, yes, that's an obvious problem that everybody's got to solve, so it will. And Martin's looking at that as part of his broader remit. And then in terms of NVG, that has been raised over the last few months. It's not something that we had been looking at, but it's something that we will look at for people. So again, just let me get the basic stuff working first, because we've got a lot on our plate at the moment, but we will then make sure that that's included.
From Steve is the next one. On the door, gas shocks. Can you test the strength of the shocks with a crosswind coming over the top of the bubble, as the door will sit out into the crosswind airstream? I will imagine that the door will be subject to slamming with a gust of wind.
they're designed to control that. That's the purpose of them being there. So they're tested in all realistic conditions. With a gas spring, it's a mixed blessing, isn't it? Because if I make it so stiff that no wind of any amount will move the door, then you're not going to be able to close it yourself. It's a big door, so there's a trade-off there. There's always going to be a certain level of environmental conditions that is just beyond the practical scope. So we'll balance those as nicely as we can, but the trade-off is the forces get very big, they get hard to shut, and the door itself starts being subjected to large out-of-plane bending forces when it's open and closed.
Good. Charles is asking, can you give a little bit more insight into what areas the owners will be building themselves as part of the build school?
Yeah, we get asked this a lot. So fundamentally, you'll have a lot to do with the composites. So you'll be building fuselages and tail booms. You'll be involved extensively in the overall assembly of the aircraft. So bringing the major modules together, the fit out of the cabin, the installation of the avionics systems, the undercarriage. Beyond that, there are lots of areas that ordinarily would be outside the scope of the 51% rule, such as gearboxes, engines, the actual manufacture of avionics, rotor blades, rotor hubs. We will involve people in that, but we will involve people in that because I want people to have a good awareness of how these systems work, what's inside the casings, what's important, so that they become better educated and more capable independent owner operators. So the course will be split roughly 50-50 between the stuff that you legally have to do to qualify for the 51%, but also the stuff that we want you to do from an educational point of view, so that you understand how that engine works, so you understand how those gearboxes work, so you understand what's important if there's a crack here or a leak there, what it is and the significance of it. Because these aircraft are going to spend a lot of time in people's hangars at home with only the owner operator to care for it, so they need that education.
John is asking, would you consider selling the GT50 as a GA power plant? I think the GT50 would be a perfect fit for the Cobalt Valkyrie C50. That's a common question we have now and then.
Yeah, there isn't a plan to sell the engine openly. For us, it would cause us more problems than it would generate revenue. So we intend to keep the engine for our products.
Okay. Michael is asking kind of a few different questions in relation to long distances of flying over the water. If the helicopter lost power, how would the floats be deployed? Could you walk us through the basic procedures? Will it keep the whole helicopter above the water, and for how long? How will this be tested?
So the floats is an area that's yet to be developed in detail, but you can expect them to operate as per conventional floats. I don't currently intend them to be automatically deployed on contact with water. The intention is it would be pilot operable with a trigger on the cyclic, so you'd arm the trigger and then deploy it at will. I think our helicopter does sit significantly lower than some helicopters, particularly the wheeled version, and so an element of the helicopter will be submerged when it's on floats in that case, because the intention is to have the floats common to both the wheeled and the skidded version. So we can't just put bags on the feet of the skids. It's got to be a body-based system.
Chuck has another question. Beautiful windscreens. How hard will it be to change out the front window if it gets damaged?
No more difficult than the window on your car. So we're using a similar process to that. So obviously you've got to be a little bit more careful. You've got to clean up the adhesive a little bit better. But yeah, they're designed to be interchangeable. And that's important because with polycarbonate front windows, they're not as robust as the acrylic ones in terms of scratch resistance.
Okay. Lance is asking, anytime a new company does something groundbreaking, there's inevitably mistakes to be made. What kind of learning are you implementing from hundreds of years of aviation experience and fail-proofs to prevent or minimize these errors?
It's a good question. There's two good answers to that. The first one is the regulations. So we benefit from the distilled learnings and failures of helicopter manufacturers for the entire history of aviation in the form of the rules and the advisory circulars that are embedded in the latest amendments of the certification standards that both the aircraft and the engine are designed to meet in their entirety. So we benefit from that. And I've always said of both HX50 and GT50 that the aircraft and the engine are very much a greatest hits album. We haven't set out to do anything novel with the aircraft. There's a couple of little bits that are novel. You know, the monolage is a little bit novel. The way we package the rotor hub is a little bit novel, and the digicockpit's a little bit novel. But the fundamental fabric of the helicopter, it's a really boring, old-fashioned design of rotor hub because we know we can make that really safely. The structure itself is a very conventional composite structure. The rotor blades are really conventional. The engine is a really conventional topology designed by a bunch of guys that spent their entire career working for other engine manufacturers. And the same is true of all of the elements that come together to make this helicopter. So this helicopter isn't a new helicopter. It's a bunch of really old ideas packaged really beautifully. And that's been our strategy from the start. So we're not trying to be too clever with this. We're just doing a good job of the value engineering and picking a bunch of well-proven ideas that we can all trust and believe in.
And talking about engines, Jason, will there be a twin engine version in the future?
Maybe. Yes. Yes, there will be. HC80 will be twin engine IFR, 8 seats, 1.375 tons. So right at the top end.
Right now, it was announced. Here it comes.
Right at the top end of Part 27. But that's a way off.
Okay. Yes.
Yes, very nice. Very excited about the future for Hill. So, Rob is asking, do you have a? This is almost a comical question because there's never a finish date for anything. Because there's always going to be, like we just mentioned, HC80 and all the rest of it. But have you got a date for this project to be finished?
This is
Obviously,
my life's work. This will never be finished. I'll always be improving it. So yeah, the program dates at the moment are as declared, but the program won't stop there. I think the very next thing that we'll do is a bunch of technology developments on top of the basic HX platform. So the dual hydraulics, the IFR capability, we need to look at some de-icing stuff, further enhancements to the 4-axis. We need to do some stuff about noise. And then once we've done those things, we can think about scaling to other platforms and other applications. But no, what we've built here is a platform for building general aviation aircraft, and so there's lots more to do beyond HX and HC50.
When will the start on the engine call? I would love to see the final silhouette, the calling of the engine.
The engine cowl.
Cowl.
Yes. Yeah. You'll see that in December. We're not going to show anybody that until then. So
there's some things of the program that we have to tell everybody that there's some things in the program that are going to be just unveiled at the right moment, right? It's going to be so expect now a lot of information being shared, but as we get closer to the date, there's going to be a little bit of fade out, a little bit of a shadowing, and then for the big unveil. Otherwise, it won't be fun, right, Jason?
Yeah, I'm not going to give you a Christmas present and then wrap it up for you, am I?
Yeah, that's a really strong point because there will be a shift. You know, we are in the process of giving regular updates to everybody, to both our customers on a weekly basis and to you guys through these AMAs on a monthly basis. So don't be surprised or alarmed when we go silent for a little while before the December event. So in December 6th and 7th is when the big unveil happens. And so there will be a bit of a time where there's going to be not much coming out in the final development of where we're at right now, because like Jason just said, you don't want to get a Christmas present that you've already had open. So the next question is, is it possible to get, is from Charles, is it possible to get a bit of a practical demonstration? I know you did this a couple AMAs ago of the size of the baggage bay. Do you have anything there, Jason, that you'd be able to show? You had at the time a luggage
I had some. I haven't.
or a
Yeah.
golf bags or something.
Can you
give
walk
me.
there, Jason? Yes, there's this request
Yeah,
comes
I
from
can.
several clients. Can you walk there and just a bit of a demonstration there with some type of luggage you can find around?
Yeah, we might have some suitcases. So if you just position yourself there for a moment, Milan. Let me see if I can find a suitcase. I think there is one in the meeting room.
Maybe Milan just wants to climb inside of there so that we can see the size of the baggage bay.
It will fit. Happening in real time. Baggage appropriation. There you go.
Yeah. So I've literally just stolen these bags from some visitors we have in the meeting room. So that's a full size suitcase, and so that goes in really comfortably. You just show that. So you've got 1, 2, 3, very comfortably, and remember that the baggage bay, if you stick your head in there, your camera in there, Milan, the baggage bay goes all the way up to the boundary where the tail boom meets the end of the fuselage. So obviously you can't stick really heavy stuff up the back because it'd cause you a CG problem. But in terms of long things like golf clubs and skis, surfboards, those sorts of things, you can use that area to accommodate the big clunky things. So yeah, it is a very, very big baggage bay. It's bigger than most of the light helicopters that you might have been used to flying or operating.
Okay.
Good.
Excellent.
Jason, as we get closer to the delivery, this is a question that is coming up quite frequently.
Yeah.
Will there be a finance package available at some point? What are the plans in that area?
Yeah, there will definitely be a finance package. We have spoken to UK-based finance houses, and they're more than happy to work with us. The challenge that we've got to get over while we're in the development phase is they're not interested until there's an asset to finance, so they need a physical asset on the ground. So I think we need to get the first few machines into the air, approved and flying, and then there'll be a wide range of people in all territories around the world that are more than happy to finance these things. So again, it's another one of the enabling solutions that we need in place to allow people to buy these. So we're looking at a range of options that include wrapping up a finance payment, an insurance payment, and your maintenance coverage within a single monthly payment, but none of that can really be developed until we're in production. So yeah, we're absolutely all over that. It's really important to us going forwards, but it's some of these things just have to be done in sequence.
Mm-hmm. Very good. And Cobus is asking about what is the aimed hours before overhaul on the power plant?
5,000.
Okay.
Right. Done. And Gary, will the inside of the windscreens be able to be fully cleaned without obstruction of the display panels?
That's a very good question. Yes, they will be, but you might need a tickle stick. So we might have to provide a little tool to help you get down there, because it is quite pointy in the nose.
Okay, excellent. And John's asking, he says, what is the lifetime for flying hours of the HX50? So obviously there's some on the market right now that kind of become a pumpkin after a certain amount of hours. So can you just expand on that again?
So in terms of the structure and the key composite components, you can expect a life on those of around 15 to 20,000 hours. And then obviously the mechanicals will just be overhauled every 5,000. Now, until we get the test data back on those from the bench, I can't tell you exactly what that overhaul will involve. All of the transmissions have been designed to do 20,000 hours as well, but we need to prove that on the bench, and we need to prove that with the final flight duty and measured loads. So it'll be a little while before I can say that for sure. but even as working machines, these machines will have very, very long lives.
Jeremy's asking, in the case that I will have to order and own an HS50 before I can purchase a commercial version, what would you predict resale value to be on the HS50 at that point in time, based on the availability and lead times? Is it still the case? So considering the demand, Jason, availability, the production capacity, what do you think is going to be the used market of the HS50 by then, when the C is released?
This is my personal opinion. I've been in and around the helicopter market for 20 years, and my view is that because HX and HC50 are identical, the only reason you would buy a C is if you were a commercial operator or you felt you needed to work it to offset the costs. Now, the vast majority of people that buy helicopters today are private owners, right? 80% of all helicopters, up to even significantly bigger weight classes than these, are owned by private individuals. And so I think the market for X will remain strong even when C's there. And the advantages of having the community, the advantages of being involved in the build and having that build school experience is a value add rather than a detriment. And you know, if you take the example of your Ferrari, you don't buy a Ferrari to rent it out to a driving school, do you? You know, it's a toy that you keep to yourself and enjoy. And so in terms of resale values, I don't think the existence of C will hurt X, because there's always been the price delta that justifies the commercial use of C. And I think no matter how many of these we sell, there is a hard upper limit as to the scale that I will build our long-term production capacity, because if you look at every new product introduction, there's always a peak of demand up front, and then it tapers off to its long-term demand, and I've got a pretty good idea of where that's going to be. And so if you look at the fact that we've got about 4,500 people as qualified buyers in our sales pipeline that are just waiting to see the engine run, to see it fly, to see it qualified, to get the first few off the production line, we are simply not going to be able to build these fast enough for a number of years. And for somebody that's just buying an X to access a C, I think there's an ability to benefit from that. There are always people that will pay over the odds for having something now and not having to wait, particularly in the premium product sector. But I'm not going to stand here and try and second guess what that margin will be, because it depends on how hard you're prepared to dig your heels in, or how much you need to sell it, as much as what the product's worth to the other person. So I think I don't think you would be in a bad position by taking the X at the moment. I think there will be a rush for these the moment the people that haven't bought yet perceive the risk to have gone.
Good, we're good. We are being mindful of time, so we want to make sure that we're not going to go too much over time, but we still have quite a few questions to cover, so we're just going to rapid fire through them. Steve's asking, in August 1st, China placed a restriction on 11 out of 14 rare earth metals in the United States. Do you see things like this affecting your production, ability to get some certain materials?
It's possible. You know, there are certain things that generally only come out of Russia or China. We're seeing significant hikes in certain elements on the London Metal Exchange. That doesn't impact us directly immediately, but we then get phone calls from our super alloy suppliers telling us that hafnium's gone up by a factor of 5 and stuff like that. And so yeah, it can affect us. We're not immune to these things. You know, we live on the same planet as everybody else, so it can have an impact. But with these rare earth metals, the one thing you've got to remember is we really don't need very much of them. So they'd have to get very, 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 very expensive before it trickles through to a meaningful cost delta on the aircraft overall. So if you look at that engine that I've just shown you, then a lot of the material weight the engine's only 100 kilos. The most expensive metals you need in it are somewhere between 50 and 100 pounds per kilo, so pounds sterling per kilogram. So the material price in there isn't a lot, and the really clever stuff like the things for the turbine blisk and the turbine blades and those sorts of things, there's only a handful of kilos of that stuff in there, and of that these rare earth metals are only grams, so I don't think it's a big problem.
Very clear. There are always trade-offs. Moving accessories from an electrically driven design to the accessory gearbox being added, what impact do we see on power, specifically engine? Power, and what accessories are we talking about?
You're talking about the fuel pump and the oil pump, and the benefit is I don't need an absolutely enormous battery. So there's some failure cases that electrical accessories would have driven the size of the battery we need to carry and created a huge weight penalty. So there's a big benefit to keeping at least some of them mechanically driven. And then in terms of power, it's driven off the gas generator rather than the power turbine, so it doesn't directly consume power from the power turbine. It just means we use a little bit more fuel to run the gas generator to the operating point it needs to be. But again, I've never declared what this engine will produce at sea level, but we've got shocking power reserves. They're enormous, so we're not going to be short of power.
Excellent. Alejandro is asking a question about the HC50. I understand the hour meter begins when the Mark the Collective is increased. Can there be installed a second hour meter that begins the Mark when the engine starts and ends when the engine is cut off for the commercial flight hours?
Yeah, it's just a software thing, no problem.
Okay.
Tim, are there any visuals of the removable soft ground landing kit?
No, because we haven't done it yet. We haven't even started that yet.
There will be, but at due time.
Yeah, there will be. There'll be great visuals too, but we just haven't done them yet.
Right. It's not essential for
Robert's
flying
asking-
right now, so everything is focused
Yeah.
on flying
Yeah,
first.
exactly. Robert is asking, can the pilot control the engine speed or use it the same way as the Bell 505? If the ECU shuts down, the pilot has no control.
It's very similar to the 505. If the FADEC fails, if both FADEC fails, you've got no engine control. But the probability of that is so, it's much more remote than having a dual failure of your electrical and your mechanical system. So it is the safest way to run the engine.
Jonathan must have a fun project at home. He says, would it be possible to buy a Hill Cyclic and a Collective stick for home simulators?
It's not something it's
Only
not
for
something I've
clients,
thought.
right?
Yeah. You can
Maybe a
have one if
client,
you.
perk.
Yeah, you can have one if you buy a helicopter. It comes with a free helicopter.
David's asking about flight software that is supported on an iPad. So the flight books.
Sorry, I don't understand that question. Say that again.
So I believe the question is about which apps will be supported for the iPad for use for navigation, things like ForeFlight, Runway Oz.
Yeah, so all of them. You can use all of them, and basically what we're working on is a common protocol for exporting the flight path data and the various other bits of data, so it will be received by our system, and we'll make that an open protocol so anybody can use it.
Okay.
Charles is asking, what internal cabin temperatures are you targeting? I can have the interior melting and screens shutting off, sitting on the ramp with 40 degrees Celsius.
So say that again.
So he's concerned about what temperature you're targeting inside the cabin, because obviously there's a lot of sun exposure, and there's going to be a potential of having the screens being affected by that. And what is your idea of just controlling that inside cabin temperature when there's a lot of heat outside?
Yeah, it's very high. It's the military spec. I can't remember what the exact number is, but it's the military spec that we're working to. So it's a very, very high temperature. We have got lots of bonded components in there. We've got lots of composites to protect. We've got lots of thermoform plastics. So all of that's really, really important. Another area that we're looking at, we're doing a lot of work on the light clusters at the moment, and they've got lots of black in them. They've got lots of plastic components in them. All of that stuff has to be managed really carefully. So forgive me, I can't remember the number off the top of my head because I literally haven't looked at it for years, but it is a very, very high number in the military spec.
Okay, we're just rounding to the last couple minutes. We're going to take a couple more questions and then we're going to round it up for today. So Daniel's asking, many cars have moved to a 48 volt electrical system. This shrinks down the electrical conductor sizes. Would it be worth considering a 48 volt standard system instead of 28 volt? This would allow commonality between automotive industry suppliers, etc.
There's only limited use we can make of automotive components. There's all sorts of commercial problems that you run into very quickly, so that's of limited value to us. In terms of the voltage standard for the aircraft, it's really to be compatible with the industry at large that we live in at the moment. As I said, the starter generator generates electricity at 400-500 volts AC, and then we can chop it up to whatever we want to. So it's something that we can play with. It's something that we can update as options present themselves. We've got a bunch of third-party avionics equipment. We've got a bunch of other bits and pieces that go into the aircraft that need compatibility. So 28 volts is a logical choice at the moment. Availability of off-the-shelf aviation grade batteries, 28 volts. So there's a bunch of reasons why that makes sense at the moment. Aviation in general is pretty boring. You know, we do things quite slowly, and that's just because we have to get all this stuff approved. So yeah, it's 28 volts for now.
Okay. Good voltage. And Samuel Kavanagh is asking, I have ordered now an X. Do I have an opportunity to get the C? Is that right? That is right. And actually, I take this opportunity to mention what are those conditions. When you order an X, you have special conditions to order the C as well before the public launch of the aircraft. Right now, it is special pricing with a £50,000 deposit. Will give you a £150,000 discount. So the aircraft of C will be at $575,000 instead of the $725,000. This is something exclusive just for the clients. That's why we already have 169 orders for Cs before the public launch of the aircraft. Also, there has been a couple of requests on what are the current conditions to order an X version. So the next serial number available is 735. That is at a price tag of £522,000. So instead of the £595,000, which is a considerable discount still of £73,000 discount. This price increases automatically every 4 serial numbers. We just had an order for 1, so the price was just opened this morning at that price, but now we have 3 instead of 4. Once these 3 are taken, the price will automatically increase to $523. And this will continue progressively every 4 serial numbers until we reach the final list price of the aircraft at £595,000, just passing the serial number 1,000. So those are the current conditions. And there's value in the positions, as you see. So when you order, you're going to be very happy to see that price continue to increase until the final list price of the aircraft. Okay,
excellent.
Misha, you want to take the next one to wrap up, probably?
Yeah, absolutely. So. So Jason, I'm just going to ask the last question from Terry here, and then we're going to close it off. So I just want to say before you answer, and you can wrap up this session here, from Ruben and I just want to say thank you to everybody again for connecting from all over the world. It's really amazing to have you on. Thank you guys for posting all of your questions. It's wonderful to be able to have Jason answer those in real time. And thanks, Jason, again for taking all of your time here to be able to answer these really important and pressing questions that everybody has. So the last question is a really great one, actually, about the rotor blade. So he gives you a big thank you for giving an update a little bit on the rotor head design and the hub and so forth, and what type of material is going to be used in the rotor blades themselves. And then we can finish it off. Okay.
So the rotor blades are very conventionally manufactured. So they're a compression molded glass fiber and Roacell basic design. They've got metallic leading edges. There's a few, there's elements of carbon fiber in there to allow us to tune the stiffness of the blades to get the natural frequencies just where we want them and the dynamic response and stiffness where we need it. But yeah, it's a very, very, very conventional composite rotor blade with British style root end details rather than the wound stuff that the Italians and the Americans like. So yeah, very, very conventional, very, very proven. The only thing that's up in the air with the design of them at the moment is how we actually choose to make the erosion shields. There are a lot of conventions for that, and we're just exploring those options before we finalise that. So yeah, very conventional. So yeah, and so in closing, just thank you everybody for your time in attending the session. Thank you for your intelligent questions, and thank you for your support, whether you're a customer, an advocate, somebody that's just interested in helicopters and watching from the sidelines. We couldn't do this without you, and we're very grateful for all the support you provide. Thank you very much.